Well, hi everyone. Working on trig functions of any angle. Um, Let me just kind of draw an angle in standard position. So there's the initial side. Okay, here's my theta. All right. Now theta goes through a certain ordered pair there. I'm just going to label it xy, a general ordered pair. And from xy, from the origin to xy, that's the radius, or r, we'll call that r. So theta is an angle in standard position, and it goes through xy on the terminal side. Now, if you notice here, here is the y coordinate, here is the x coordinate, and it's actually negative here, but it doesn't matter. But to find r squared would be x squared plus y squared. And reason I'm saying x doesn't matter as far as finding r, because when I square negative I still get the positive. So r is the square root of x squared plus y squared. Now, if I go with this reference angle, theta prime, it's going to have the same trig functions as theta. And the if you'll notice, the sine of theta is the opposite over the hypotenuse, which I'm going to write as y over r. The cosine of theta is the adjacent over the hypotenuse, which is x over r. And the tangent of theta is the opposite, which is y, over the adjacent, which is x. So, and then we could go off of that. Cosecant of theta is r over y, using these reciprocal identities. Secant of theta is r over x, and cotangent of theta is x over y. Now, let's say I have, I'm going to go example 1 here. Let's say I have an angle in standard position. So we're going to let negative 2, 3 be a point on the terminal side of theta. Let's find the sine of theta, cosine of theta, and tangent of theta. Alright, I still like to illustrate it. Even though we have all this, it's still nice to see it. So 1, 2, 3, 1, 2. There's the terminal side. Initial side is always this. Okay, so here's theta. That's theta right there. Now, still, if you think about it, that's 3 there. This is negative 2 here. So even without knowing these identities, you still can use SOHCAHTOA to get what you need. Now, I am going to calculate r, and it's the square root of negative 2. Well, which equals square root of 4 plus 9, which is square root of 13. So r is the square root of 13. So the sine of theta is 3 over square root of 13. The y, it's the y over r is the square root of 13. And I'm going to rationalize that denominator. And I have 3 radical 13 over 13. The cosine of theta is the x, which is negative 2 over the square root of 13. You know, sine is positive here and positive here. Cosine's positive here. Cosine's negative here. So this is an illustration of that. I'm going to rationalize the denominator, and I get negative 2 radical 13 over 13. And then the tangent of theta is the y, which is the opposite over the hypotenuse. No, it's opposite over adjacent. Y over x, 3 over negative 2, negative 3 halves. Okay. Now, let's call now I have doubts. Was I showing you all this stuff? Let me keep that there for a second, and you can pause if you need. I'll try to be more aware of the camera and the location if I was off there. Alright, now finding the other trig functions, knowing the value of one trig function and one more piece of information. So that's kind of what example 2 is doing here. So we're given that sine of theta is negative 4/5 and tangent of theta is less than 0. We're going to find the cosine of theta and the tangent of theta. Now, tangent is positive here. It's sine over cosine. Sine and cosine are both positive. It's negative here because the sine is positive over the cosine, which is negative. It's positive here because both sine and cosine are negative, so sine over cosine is positive. And it's negative here because cosine is positive, but sine is negative over cosine, which is positive. So the sine is positive 4/5, and tangent is less than 0. So we are in this quadrant. We're in quadrant 2 here. Now, we're going to find the cosine, and if we're in quadrant 2, the cosine is going to be negative. So what we could do here, okay, what I'm going to do here is I'm going to just visualize it. I do know it's in this quadrant. The sine is the y over r. So I'm going to just kind of create a sine of theta is y over r. That's another word saying opposite over hypotenuse. So I'm going to go up like 1, 2, 3, 4, and then just kind of draw on radius here. So this is 5. This isn't a very good place to put that. Here's 5. Let's draw this. Here's my theta. Make sure we're all good that knowing since tangent is less than 0 that we are in the second quadrant because the sine is positive. This is 4. Here's the x value. So I'm going to go to find the cosine of theta. And in order to do that, we need to find that x value there for that triangle. So r is equal, I'm going to use Pythagorean theorem. R squared equals x squared plus y squared. And r is 5, so 5 squared equals 4 squared. No. X squared plus 3 squared. 4 squared. Anticipation there. 25 equals x squared plus 16. 9 is equal to x squared. Now, x is actually equal to plus or minus 3. And it's actually negative 3 this time because it's in the second quadrant. So x is negative 3. Cosine of theta would be adjacent over hypotenuse. So cosine of theta is negative 3/5. Got to get that sign right. Tangent of theta is negative, or it's y over x, which is 4 over negative 3, or negative 4/3. All right. Let's call this example 4. Am I missing one here? Let me check here real quick. All right. Recalculate. This is example 3. When you use the function cosine of theta equals negative 4/9, where theta is in quadrant 2, and we're going to use that to find the cosecant of theta. So, now, cosine is negative 4/9. So, what I'm going to do here is, again, kind of visualize the triangle. I'm going to go negative 4 units this way, and then I'm going to go like up here a ways and put 9. Okay, I'm just putting that point on here, and here's my theta. So we want to find the cosecant of theta, and this is negative 4. I would really like to know what that y value is. And negative 4 squared plus y squared is equal to 9 squared. And that's 16 plus y squared equals 81. And y squared would be 65. So y is the square root of 65. Now, this is theta prime is our reference angle here. The opposite over hypotenuse, so the square root of 65 over 9, that is the sine of theta, which is going to lead me to the cosecant of theta, which is 9 over the square root of 65, which is or let's multiply that by the square root of 65 over the square root of 65, and that'll give us 9 radical 65 over 65. And that, I think, is all it's asking for. That is the secant of theta. All right, guys, you take care.